direct from HyperMesh. We've got some updates on parts, some updates about generic assembly, so both parts, subsystems, and materials, so access to the library, preference options, with some updates to Renumber, and then finish off with some updates to subsystems as well. So touched a few different areas across this release. So let's kick it off with the exciting one of AMDC.
Thanks, Greg. So hello, everyone. My name is Vikas Ahir. I'm, as Greg said, and I'm the product manager for model assembly, and I'll be walking you today through our latest integration with AMDC. So before I jumped into AMDC, I would like to touch base on something that we already have. Today, we have HyperMesh material library already integrated in HyperMesh, and we are building on top of this with AMDC. So the current material library allows you to do representation and revision management of materials. You can manage materials from multiple disciplines in a centralized library, facilitating the solver interface specific representations. You can do also revision management. It allows you to maintain your materials consistently, as well as allows you to have a traceability. Having touched based on that, let's go to AMDC, the exciting material management experience that we have from Altair One team. It's, as you all know, it's a state-of-art solution that transforms the approach to accessing and managing and leveraging the material data for product development. This is a very intuitive experience that encompasses efficient data utilization. It redefines the way material data is utilized for streamlined product development. It has a very streamlined workflow. It involves very minimal local material management. It's very comprehensive material database. You can find a lot of materials in it. It's pretty diverse too, and it gives you an accurate insight so that your properties are always up to date for precise simulation and analysis. Let me minimize this. Okay, so by providing the HyperMesh, the interface between AMDC, we have streamlined the workflow to improve the simulations and boost the product design and performance. So with this integration, what you're gaining is you're gaining an enhanced material insight. You can seamlessly access the AMDC's extensive material database from within HyperMesh. You don't have to leave the HyperMesh interface. You can easily access all the materials that are available in AMDC. This actually streamlines your workflow. It eliminates the manual data entry, and also then the manual data entry is eliminated. So subsequent errors that pop in due to manual entry are also eliminated. It also helps you with the precision in simulation because you're bringing in the latest and greatest data all the time from AMDC. So your material deck is up to date, and it enhances your reliability in product performance and predictions. It also optimizes the design iteration because you're always accessing the right material without having to worry whether something is not right or wrong. Having said that, there is a collaborative efficiency also. The plugin that we are using is something that we have developed with in conjunction with AMDC team. It's a common plugin that is used by Inspire Mold and also the SimLab. So whatever enhancement are done for one software, every software gets it. And because we are using a common plugin, our installation footprint is also minimal. So that also helps us in keeping our footprint minimal, whereas sharing all the enhancements we are doing across Altair products. Now let's have a look. I have a recorded video wherein we show the HyperMesh AMDC integration. The integration is launched from the materials browser. You go to library, load from AMDC, and this will give you a login. I'm gonna pause this for a second here. For accessing the material in AMDC, you need to have an Altair One login. So the customers have to have Altair One login available to them, and they have to utilize that login. As you can see on the screen, this is the exact web interface that you will see if you're logging in from a web page. And this is the advantage of using this plugin because it gives you a seamless experience as you would get from a web page. You can actually look at all the user properties and everything. Please note I had clicked on the white space here, so there is no material selected. But one thing that you can notice is the solver template is pre-populated based on the profile from which I launched this particular integration. You can validate the properties and then give a material ID for HyperMesh and download the material. You can download material and the screen will stay in case you want to download another material, and so on and so forth. You can download a lot of materials, all the materials that you need in this fashion. And that way your session you don't have to always right click and start it per session, per download. This is one example of how you can access the material. The other one is you already have a material. So here I'm just showing all the material properties that are available once you download this. Let's say I have a material already and I want to just download that. So if I select that and do from AMDC, the material will be pre-populated and the query will show the result. This way you don't have to really run the query again for the material name and everything. So this is how the integration work. It might look very simple, but this is the first phase of it. There are a lot more enhancements will be done, and we are very excited to give this out because a lot of customers have been asking about it. Now, now there will be a question like we already have a material library and we are also having AMDC to when to use what. So we have prepared a slide to let you know when you should choose material library versus when you should use AMDC. So material library is primarily a framework that can manage a database for you, the material database. So if the customer has an existing database and he's not willing to, trust anybody to upload it into the cloud, then the solution is obviously a material library. They can capitalize on material library for quick and efficient model updates using the material library. But if the customer is new or his requirements are very specific for a material, which are already available in the specialized needs are already available in AMDC, then we should suggest the AMDC so that they can leverage AMDC for simulations that need the precise data. So this way, there is a clear distinction when to choose what, and both systems are going to coexist. And you should be very clear when to suggest what. Of course, both systems are available out of the box. For AMDC, you need to have Altair 1 login. Material library comes readily available out of the box with HyperMesh installation. The future enhancements I talked about, right? So those are the multiple downloads from hosted DB. So in pretty AMDC is already supporting hosted DB, that is, or a private DB. And if such a private DB is accessible to the customer, then he can download multiple materials in one go, in one query. That is something that we are working on that will be made available in future. Currently, when you download a material from AMDC, and if you already have that another material with that name, then the material that is downloaded from AMDC will be material with the name .01, the same name, but it will be appended with .01. So we are not really doing replacement there. We are creating a duplicate for the user to manage. So there is no redundant entity management right now. That is something that will be brought in future. And of course, some of you might be interested in scripting this workflow and wanting to download this without GUI via API. So APIs will also be made available in future for the users. With this, I'm finished. So I'll hand over to Andreas for the next phase of our presentation. Thank you very much.
Thank you, Vikas. Hello, everyone. My name is Andreas Oharopoulos, and today I'm going to talk about party presentation controls coming in HyperMesh 2023. Before I dive into the details of representation controls, I'd like to start from describing the current practice, that is until 2022.3, to create custom party presentations. So user representations enable the creation of custom part reps until now, utilizing parameter criteria files provided by the users. It was only possible to create cell and solid representations, and there was a special procedure to create mid-mesh reps. But the whole user interface Gate was good enough to do the job, but had some issues. For example, you couldn't delete the default user representations, and you should also be applying the changes on its user rep definition before creating a new one, and so on. Also, providing parameter criteria files to define a custom user rep was not exactly the easy thing to do for less advanced users. So due to all these limitations, I'm really excited to announce that representation controls are going to be introduced in HM 2023 as an enhanced replacement of user representations. in order to further streamline the process of creating custom representations and to make it more accessible to non-expert users. Rep controls are essentially customizable meshing templates that allow users to create part representations by launching a batch mesher through the part browser. The whole idea of having reusable meshing templates that you can then apply on multiple cases is similar to the connector templates that are already available in HyperMesh, and they're known as connector controls. Each rep control has a unique name and type assigned by the user, and in 2023, all saved representations are going to have a representation control assigned. This is the reason why when saving a representation in 2023 with a custom name, a control of cell type is automatically going to be created, which the user can later modify, and this is also going to be automatically assigned to the representation. After going through the fundamentals of rep controls, we can now see how to create and modify them in more detail. So the place to do all these actions inside HyperMesh is the Representation Control Manager dialog, which you can access either through the newly added icon in the assembly ribbon, or by right-clicking anywhere in the part browser and selecting Representation Controls. In this dialog, you can create new controls, edit the existing ones, or even delete controls, including the default ones, which is something you couldn't do with user apps. And also, you might notice that the icons displaying the type of the controls are the same with the ones you find on the respective ribbon tools, since the technology behind the ribbon tools and the controls regarding meshing is essentially the same. Also, its new control, when created, it has some pre-populated options, which are there to assist non-experienced users to quickly ramp up with the workflow. Of course, more control types and options from the remote tools are going to be added in the future. Since user representations will no longer be available in 2023, any existing solid and cell user reps are going to be automatically converted to Tetra and cell rep controls on the first time you launch HyperMesh 2023 on your machine. And at the same time, a new file called repcontrols.cfg is going to be automatically created in the starting directory of HyperMesh, which is going to keep all the info related to the rep control definitions. The introduction of this new file also ensures that your existing user presentation definitions, which are living in the batchmesher config 2019.cfg file, won't be affected by 2023 and any later versions, so that you'll still be able to use both user reps and rep controls on the same machine without any issues or classes. Also, it's worth mentioning that in 2023, when connecting to part libraries containing user reps, those are going to be automatically converted to rep controls. Just like you used to do with user reps, rep controls can also be used for meshing standardization in enterprise organizations, meaning that users will be able to pull rep controls by connecting to a shared library, ensuring this way that all team members can be using the same control settings to ensure consistency between them. The users, of course, can also experiment with new controls locally, and if they want, they can just push them to the library by saving a representation, and then we'll also save the control assigned to the representation into the library automatically. The current implementation has a limitation regarding overwriting representation controls in the library, which is that once a control has been saved in the library with a specific set of values assigned to it, then if you change your mind and want to change some of these options on the control, it's not possible to push the changes in the library. However, you can still be using the updated control locally. It's just not possible to push the changes in the library. And this limitation is going to be erased in the future as well. We can now watch a short demo of how representation controls can be used to create new custom representations. And we're starting in HyperMesh 2022.3, where we can review we have a cell and a solid user rep. So when switching to HyperMesh 2023, we can see that the user reps are converted to a cell and a solid rep control, a tetra rep control, we then connect to a part library connecting a rep control. And we can see that the rep control is immediately pulled in session. It's the frame rails one, we can see. And moving on, we create some new rep controls. You might notice here that most of the options available in the ribbon tools are available already in most cases, and what's missing is going to be added later on. Here we have a mid-mesh control, then rigid body mesh control, and finally we have cell control. And it's worth mentioning that for cell controls, you still need to specify a parameter and criteria file, as you used to do with user reps in the past. We continue by opening an HM model, selecting some parts, and then click on representations, create, select your controls, and click OK to launch batch mesher and create your representations. In HyperMesh, all parts have a PDM mesh flag attribute, which is basically used to determine the way that the parts should be modeled. And sometimes design teams assign this PDM mesh flag attribute, or other times the CA engineers do so. So as you might already have noticed, all rep controls also have a mesh flag attribute on them. And this is happening because there's a new option, a very powerful option in the create representation dialog, which is called automatic. So when this option is selected, HyperMesh checks if any of the PDM mesh flags assigned to the selected parts are matching any of the mesh flags assigned to the controls. So the matching controls are then used to create representations for the given parts. For example, in this slide here, we can see in the image in the middle that we have a control named cast parts with its mesh flag set to casting. So if we select, let's say, a part with its PDM mesh flag also set to casting, and then you click on rep create and you select the automatic option, then HyperMesh is going to pair up the part with the control, and we'll know that a representation for that part should be created using the cast parts control. In previous versions, SMT and SMH PDM mesh flags indicated that the part is going to be meshed using solid elements, and those flags should be set on a part in order to create solid mesh for it. This is now optional in 2023, meaning that tetra and other solid representations can be created without mesh flag assigned. However, there are two default controls, tetra 5 mil one and a hexathin solid 4 mil, with the SMT and the SMH mesh flags preset, so that it's easy for users with legacy models to use the automatic functionality I just described out of the box. We can now watch a short demo of how to create representations by mesh flag, starting by assigning mesh flags on some of the existing controls. We have here, we have a tetra, a mid-mesh, a bounding box, and a cell control. We have already defined the PDM mesh flags on the parts that we now select, and click on rep create, select the automatic option, and then you just click OK. A batch mesh session is launched, and all your representations are created with only very few clicks. Since the PDM mesh flag is no longer dictating the element type, as I said, that a mesh representation should contain, the logic behind rep update has also been updated. So if a control is assigned to a representation, which means that the representation's name is matching the name of an existing rep control, when you click on rep update, in that case, a property will be assigned to the part based on the control's type. For example, let's say you have a tetra rep control named tetra mesh, and you also have a representation saved with the same name. So in that case, when you click on rep update, you're going to get a solid card image due to the control's type. In case a control is not assigned to a representation, but the PDM mesh flag has been defined, and it's matching the mesh flag on one of the controls in session, then on rep update, you're going to get a property, again, matching the control's type. For example, let's say you have a part with a PDM mesh flag set to test, and you also have a hexa control with its mesh flag also set to test. On rep update, you're going to get a solid property. In any other case, on rep update, you're going to get a cell property, since this is the most commonly used property type. Another enhancement that has to do with the mid-surface extraction through part browser is that in 2023, when common refs are created, BatchMesher automatically detects areas of different thickness and assigns them to separate components under the part. After that, a property is created for each of these components, and the automatically calculated thickness value is assigned to it. But as in previous versions, if the part's PDM thickness is set, then the multi-thickness detection is disabled, meaning that the user-defined value will win over the calculated value. That's all from my side, and I hope you're as excited as I am about rep controls, because they really are a very big step forward, especially compared to user presentations. And now handing over to Dimitris. Thank you.
Thanks, Andrea. So, hello everyone. My name is Dimitris, and I'm going to talk to you about some very useful enhancements that we are bringing in our new version. First one is attribute tables. This is an enhancement regarding part browser workflows. We are bringing this enhancement to part browser since it is already there for other browsers. And I'm talking about the ability to right-click on some type of data in the entity editor and adding a new column in the part browser for the specific type of data that were selected. The supported types of data currently are library data, representation data, PDM, and metadata. This means that we are now offering this ability to the users to populate the part browser with the desired information that they need from their parts, and to better organize their part browser and being able to interrogate and overview their models. A simple demonstration of the new feature coming to part browser is as simple as you may know. We are navigating through the entity editor. We are right-clicking, add column, and if we scroll to the right in part browser, we can see that the new column is added. We can do this for as many data as we want, and as you can see, even though I have just selected one part, the information is populating each part that has the specific data assigned to it. And if someone wants to delete some columns, all they have to do is right-click on the top of the part browser and uncheck the boxes of the desired columns that they want to delete. Next enhancement that I would like to talk to you about is assembly preferences. This is a new preferences section that we are introducing. It is consolidating two already existing options. The first one comes from the browser's preferences. It is the part browser one that lets users choose to show components in the hierarchical view or not. And the second one comes from PDM connections. It's the BTM live one that you see in number 2 that lets the user check for updated parts with some time step. Now, not only that, we're not only consolidating two already existing options, but we are introducing a new one, as you can see in the middle of the left-hand side dialog. As you can see where the arrows are pointing, this new option is called CPUs used by BatchMesher, and by default, until now, BatchMesher was using the number by default the numbers of system CPUs -1. This was something that the users could not put their hands on, and we are offering exactly that, meaning that we are offering the users to choose between auto and manual mode, which means that when auto mode is selected, the behavior is going to be, as I just described, the number of system CPUs -1. And when manual mode is selected, for example, here I have selected 4, the user can specify the desired number of CPUs that are going to be used by BatchMesher. This means, for my example, that when BatchMesher is running, I'm going to see 4 jobs working on at the same time in BatchMesher. This is a very useful enhancement, especially for users that have very high demand on resource management and they want to have control over their system's resources. Now, the last enhancement that I'm very excited to talk about is Library Manager. Library Manager is a new dialog that we're introducing to enhance our libraries workflows. as you may know, one of the first steps, if not the first step in libraries workflows, is to connect a register and then connect to a new library. In order to do so, until now, someone would have to navigate through 3 different browsers and 3 different right-click context menus in order to connect to each type of library. As you may know, we have part, subsystem, and material libraries, and we are essentially merging those 3 library dialogues into one, which is called the library manager. And therefore, we are simplifying registration and connection of libraries. We are greatly reducing the number of clicks needed in order to do so. And we are also reducing the time consumed by the users. And not only that, we are also providing a quick access to this new library manager. And this is through a new icon that we are introducing in the assembly ribbon. As you can see on the top, the new icon is called Libraries, and it is the Organize section. By just clicking on this icon, Library Manager is directly accessed. To give you a better overview, for those not so familiar, we had on the left-hand side 3 identical dialogues that were doing exactly the same thing, and their purpose was to connect, register, and switch between libraries. Now we're combining those 3 into one library manager, and we are giving the users the option to register and connect much faster and even switch between libraries much faster than before. A few points worth mentioning here for the new library manager is that when a library is connected, you're going to see a blue check mark placed on the left-hand side of the part library, or for example, the part library name, as you can see at the top. And if you want to disconnect from a library, again, for the part library here, you just click disconnect on the right-hand side of the library type. If someone has a very long list of libraries, we are offering the search by library name bar on the top to save you some time from scrolling through the library list. Last thing that I would like to mention is that, as you can see, we have transitioned from a vertical orientation of the dialogues to an horizontal one. This is aiming to make the dialogue easier to use, more intuitive, and more eye-pleasing, making it fit better to the new HyperWorks interface. Thank you very much for your attention. I will pass the presentation now to Greg.
Thanks, Dimitri. Okay, so the first thing I'd like to go through is some of the updates to Renumber. So the first change we have is the Show IDs on selection option has been removed. So we're now using the Control Q shortcuts or the right-click Select Show IDs option. This option was there in 22.3 when in idle state, but in Renumber there was like a secondary conflicting mode that was just for Renumber tool. So we've removed the kind of custom Renumber one, and we've now got this consistent mechanism regardless of where you are in HyperMesh. The old method had some issues where, for example, if you went into Renumber with some IDs displayed, you renumbered them and then exited the tool, it would turn off the IDs because you'd been in Renumber and were using a different display method. So now we've got this consistent method regardless. So you can select some nodes here. So I'm just selecting some nodes outside of Renumber tool, Control Q shortcut to turn the IDs on. I can go into Renumber. I can change the ID of it, which obviously then is updated. And the display is also updated, and then I can exit Renumber tool and it's still maintained. So we just got that consistency both in and out of Renumber tool for displaying IDs. One more change is in the text box. We now display unresolved entities. So sometimes after importing a solver deck, there might be an entity that's referenced but not explicitly existing in the HyperMesh session. And in this case, unresolved IDs are used to kind of capture and maintain that ID. Those IDs can't be taken when doing renumbering. Previously, the Renumber tool kind of didn't indicate that, so you might have been a little confused why certain IDs or gaps are taken and not used. So this helps to show you why those IDs can't be used. And this is also the final piece of the panel functionality that was there for the renumber panels, was that information appeared in the status bar at the bottom. And one final change, again related to consistency, is the removal of the ordered checkbox in the renumber tool. So in other tools in HyperMesh, when you want to have a selection that is based on the order that you select things, where that order is important, there's this list selector. So instead of using the ordered checkbox, which again was kind of custom for renumber tool, we're using the generic selection mechanism now of lists. So if you select nodes and pick a load of nodes and renumber them, the order you selected those nodes doesn't matter. If you pick node list and then pick nodes, they will be renumbered in the order that you pick them. And that applies to all of these list selections that are available. I'd like to move on to some updates for subsystems, and these have come across a few different tools. So the move tool now supports subsystems. Any entity, so the subsystem is like a collection of other entities, and kind of like a big assembly. And any entity that's supported by the move tool will get moved when you move a subsystem. And those entities that aren't supported with move, even if they're in a subsystem, they also won't get moved. So it's basically a big reflection of whether we can move things or not. As we move the subsystem, the position matrix on the subsystem gets updated. So we remember that you've moved your subsystem. And that allows us to give proper positioning during representation load. So one thing we can do is we can take kind of a default subsystem. So in this example, we're bringing in a seat. It comes in like a generic location. We can then obviously position that seat where we want within our model. So I'm just using kind of the bolt hole as a locator to find and match it, so that we can put the seat in the right position. And now as we do representation management, and if we wanted to unload and load this representation, the fact that we've moved the subsystem is remembered, and it will come loaded in the correct position. So we'll just do that here, and we can load back that in, and it will come in the remembered position. The same thing applies for mirror tool. So the mirror tool now supports subsystems, and the same position matrix is updated as you perform a mirror. So again, we will remember as you do the mirror, wherever you put your subsystem combination of move and mirror, we will remember that for loading representation. So you can now kind of take any subsystem and position it where you want. We need both of those things for subsystem instancing. So we can use subsystem instancing now to simplify our modeling, to easily duplicate content. So in this example, you can just see there's just a set of wheel that we're going to duplicate and move to another location. So in this way, any kind of big models that have repeated assemblies, we can use subsystem instancing to duplicate and push those changes. This will have a familiar feel to those used to part browser, because it's based on the same paradigms as the part instancing technology. So those who have learned one workflow should easily pick this one up as well. So one thing we can do here, we can take two subsystems. These are a left and right hand door. They're both instances, or they are an instance of each other. So we're just going to do like a rebuild on the trim, delete one of the parts. So you can do whatever updates to one. It's just an example of, so just to add a comment of what we've done. So we removed the glass and we coarsened the trim. We save the representation of the subsystem we've modified, and then on the other subsystems that we want to absorb those changes, we can load the representation, and that will bring in the updated content. So that's our method of pushing from one instance to another. So kind of taking a look at kind of some of the technical details. So one thing you will notice there is that we required the saving of the representation. So instance sync, which is available in parts, is not quite there yet, same as instance break. So we have a slightly different workflow for the initial implementation. The other thing worth noting is that to create an instance, a subsystem representation is required. So if you have a subsystem and you go to instance it, it will first prompt you, if you haven't saved it, to save it. And all that will mean is you create a representation that we then obviously duplicate and then allow you to reposition. So it's handled for you and you'll be automatically prompted if needed. It's just worth being aware of and not surprised when that dialog comes up. We support a hierarchy of subsystems. So when you've got a hierarchy of subsystems, our initial implementation only supports instancing of the lowest level subsystems. And also in 22.3, when loading a subsystem, it used to remember what other subsystems it was connected to and try to reattach itself to those with this auto equivalence mechanism. That was causing some conflicts with instancing, so that has been temporarily removed for the 23 version as well. But overall, it should be a really exciting method in order to kind of massively reduce the amount of repetitive work for whether multiple doors, multiple seats, whatever it happens to be for your model. So I think that about sums it up. So thank you very much for your attention for all the presentations